split up the, like without using that actual general function, if you split this up, you can split it up into the integral of x from 0 to x, this and then minus, like that.
Yep, that'll work fine.
How do you do
but
this?
That'll work fine, but you still can't just use this approach because you still don't just have an x. So you're still going to have to use this part of the function. Although there, at that point, you can kind of just use the chain rule, basically.
Right. So I was wondering, how do you use the chain rule in this case? Is there like some kind of u substitution or?
Sure. Let's take a look at that. So. Okay, so another way to rewrite y is like this. And here, you've moved the bottom limit up to the top, so you also have to change the sign. All right, and now you want to use the chain rule just to evaluate this term. Well, let's see. I want to find the derivative of this. So our outside function here you just treat this whole thing as the outside function, and clearly the cosine is inside of that. The cosine is inside of that, so this would be the inside function. And then the chain rule tells us that the derivative is the derivative of the outside times the derivative of the inside. Well, the derivative of the outside here, now for that, we could just use this formula, which is the one you learned in your course. So the derivative of that would just be cosine t squared. But what should we plug in for t? We should plug in u. And what should we plug in for u? Well, we're evaluating that at the inside. So we would plug in the cosine term. And to use the chain rule, we should be multiplying that times the derivative of the inside, which is negative sine x. And now we've gotten the, so this would be negative, and then there's another negative sign in front, so you'd end up with this positive term, which is the same thing that we got anyway. So in a sense, you've kind of just used the chain rule to prove this formula. So actually, it sounds like the way I taught you this is different. So basically, they gave you the hard method in your course. In your course, they told you to break this into pieces and use the chain rule on each piece, and I just kind of gave you a cookbook formula for that.
Okay.
If they didn't give you this formula in class, I don't know. I guess you would get. I think you would get full credit for using this, but maybe they want you to use the chain rule.
Okay,
so.
that's fine. Yeah, I can explain it to you later.
So the key is that the inside function here is this cosine term, and the outside function is the whole rest of the business. So then we can find the derivative as the derivative of the outside times the derivative of the inside.
How would you write that though? If it's if you say that u is equal to cosine x, then du is equal to negative sine x? Is that how you would write it?
So u is cosine of x here, so the derivative of u with respect to x is negative sine x.
Okay, so then when you write it in the integral again, it'll be integral from 0 to u cosine t squared dt. You would just plug in u for cosine x. And then you would do the same thing that we did before.
Right.
And then that would be cosine u squared. Right, and then it'll be cosine u squared.
So here's how you would write the chain rule. It's the derivative of the outside with respect to u And u is our inside function, so then the derivative of u with respect to x. And now we're all ready to put in the pieces. The derivative of this with respect to u is just cosine of u squared. And the derivative of u with respect to x is what we figured out over here. Negative sine x. And we have to plug in for u. Well, u is just the inside function, so that would be cosine x. All right, and again, I think we ended up with the same thing that we had before. If you here we have a negative sign, and that'll cancel with this negative sign here. Those are pretty tricky. Well, even if you do it using the chain rule, you might want to check it by using this cookbook formula.
Yeah. Okay.
This formula itself is actually not that complicated once you get comfortable with it.
Can we do number 14? I mean, I'm sorry, 15.
15. Okay, how would we start on that? Shot.
We would use u substitution again, right?
I don't think so.
Oh.
What u substitution would you make?
Would you do 1 over square root x plus integral of, so you just split it up?
Yeah, that's a better approach.
Okay, then I'm fine with that one, I think.
How do you know that you shouldn't use the substitution approach? Because nothing is the derivative of anything else here. Nothing here is the derivative of anything else. But if we just split this up into the sum of two separate things, it's pretty easy to take the derivative.
Okay. Can we do number 21?
So the general rule here is if you have a sum in the numerator and one thing in the denominator, you can always split it up into separate functions. And that will be easier to take the derivative of. Which question were you looking at?
Actually, number 22.
22, okay. And substitution method isn't so good here because, again, nothing is the derivative of anything else here, so it's not going to simplify much with substitution. And anyway, the method that we just put on the board would be easier.